Welcome back to the Math Professors. We do videos ranging from algebra, statistics, pre-calculus, calculus sequence, differential equations, and so on. These videos are free, so please subscribe, like, or share to help us grow this channel. So today we're going to cover probability distributions, and really in this case we're going to cover discrete probability distributions. So first I need to do just a definition and then the requirements for a probability distribution. So a random variable is a variable that has a single numerical value determined by chance for each outcome of a procedure. And then the requirements for probability distributions are, the first one says that there's a numerical random variable x, and for each x there are corresponding probabilities. The second requirement says that the sum of all the probabilities for each x adds to 1. And we'd like to notate that as the sum of p of x is equal to 1 for all x. And last, it says that 0 is less than or equal to p of x, which is less than or equal to 1 for all of x. Now, in my opinion, this is a little redundant because I said that all x's have a corresponding probability, and to be a probability, you have to be restricted between 0 and 1. So we'll look at this a little more later as far as the third requirement. We'll just kind of check it at number 1. All right, so let me give you some examples to see what a probability distribution might look like, and then kind of verify that it satisfies or may not satisfy the requirements. All right, so here's our example. So let's consider two births, or a family of two, and we're really just looking at their children, where x represents the number of girls. So we have to kind of go through the requirements. Remember, the requirements are, is x a numerical value. So, requirement 1, is x a numerical value? And, associated with probabilities. Well, what we know is we're talking about number of girls in two births, so we know that the number of girls, you could have, 0 girls, and as far as children, I could have, 1 girl, or I could have 2 girls. So if I have 2 children, this is what could happen. I could have no girls, which means I'd have all boys. I could have 1 girl, which means I could have a girl and a boy, or a boy and a girl, depending, remember, order. And in this case, I'd have, 2 girls. So these are the possibilities for number of girls. Now, when I'm asking if they're associated with probabilities, I'm going to have to find the probabilities of each one of these numbers as well. So for instance, what is, the probability of 0 girls? Well, in order to determine this probability, let's look at our sample space. So the sample space is, we know we can have, 2 boys. I can have a boy first and a girl second. I can have a girl first and a boy second, or I can have 2 girls. So these are all the possibilities for births in order. So 0 girls would represent 2 boys. And this would be, 1 out of the sample space of 4. So the probability of 0 girls is 1 out of 4. Or I could say 0.25 if you want to write this in its equivalent decimal. So probability of 1 girl, well, the probability of 1 girl is going to be either this one or this one out of 4. So this is going to be equal to 2 out of 4, which is equal to 0.5. And then finally, the probability of all girls, which is going to be 1 out of 4. So P of 2 is going to be equal to 1 out of 4, which is equal to 0.25. All right, so, is this true? Yes. Yep, so it satisfies the first one. For the second requirement, we're basically verifying that the sum of all P of x is equal to 1. So let's look at the sum of all the probabilities. That's adding all these things up. So the sum of the probabilities is, this is, P of 0 plus P of 1 plus P of 2, because these are the only 3 numerical values and the only 3 probabilities. So when I add these things up, this is 0.25 plus 0.5 plus 0.25, which indeed equals 1. So boom, that one works. And then 3, we have to verify that 0 is less than or equal to P of x, which is less than or equal to 1. I'll show it for this example, and then we'll just kind of not really glaze over it, but kind of point at the 3 probabilities. So every single one, I can see that 0 is less than or equal to P of 0, this probability, so 0.25, which is less than or equal to 1, which is true. 0 is less than or equal to 0.5, which is less than or equal to 1, that one as well, that one. And then 0 is less than or equal to 0.25, which is less than or equal to 1. And again, we can tell that, remember, these are probabilities, so they should be bounded between 0 and 1 inclusive. So again, yes, this is a probability distribution. Now these things can come in other forms. So I can actually write this as far as like finding all this information. A lot of times they give us all this information in terms of a table. So I'll erase this spot over here and show you that it's equivalent to what we've done here. So if I wrote this in table form, what you'll usually see in an example, it'll give you a table and it'll say, does this table determine a probability distribution? And I'm going to use exactly the same thing. So I have my numerical values for x are 0, 1, and 2. Their associated probabilities, so p of 0 is 0.25, p of 1 is equal to 0.5, and then p of 2 is equal to 0.25. So if they give you this, you can do the same kind of check. Is a numerical, is that random variable numerical and associated probabilities? Yes. Does the sum of p of x equal to 1? Yeah, if I add all these things up, it is equal to 1. And of course, these three things, each one of these things are between 0 and 1. All right, so let's show you another example. All right, so the last part of this example is to show you that it can also come in relative frequency distribution form. So this is another representation of this exact same probability distribution, where the heights of these bars correspond to the probabilities. So you can see that x is numerical, 0, 1, and 2. It's associated with probabilities, which are the heights of these bars. So the probability of 0 is 0.25, the probability of 1 is 0.5, and the probability of 2 is 0.25. And if I want to add up the probabilities, it's the same thing as adding these things up, and you can see this is equal to 1. So this is another look at a probability distribution. All right, so here are three examples, and I want to determine if, which or if any of these are probability distributions. So we're going to fly through the requirements. So looking at the first one, what we have to do is we have to verify is x numerical and then associated with probabilities. Well, the problem here is x is not numerical. Yes, no, and maybe are not numbers, so they're not associated. They're not numerical. So they are associated with probabilities, and the sum of the probabilities does equal 1. But first, this is no, x is not numerical. For this one, if I want to ask this says the number of jobs, the number of interviews before given a job. So we can see that some professionals said, oh, 1 interview, 30% gets a job, 2 interviews, 26% gets a job, and after 3 interviews, 10% is given the job. So, 1, x is numerical, it's associated with probabilities. But the reason why this is not a probability distribution is because when I sum up p of x, you can see that this does not equal 1, so 560.66. So this, does not equal 1, so therefore not a probability distribution. No. The sum of p of x does not equal 1. Now over here, I'm given a formula. It says p of x is equal to x over 3, or x is the set 0, 1, and 2. So let's see. So first, is x numerical? And also associated with probabilities. So 1, yes, x is equal to the set 0, 1, and 2. So x is numerical. Those are the numbers. The numbers. P of 0 would be equal to 0 over 3. P of 1 would equal 1 over 3, just plug it into this formula, and then P of 2 is equal to 2 over 3. So this is equal to 0. This is 0.3 repeated and 0.6 repeated. So yeah, they're associated with probabilities, and these numbers are between 0 and 1. So really the second step I have to check is does the sum of P of x equal 1? Well, that's going to be the first probability, which is 0, plus the second probability, which is a third, plus the third probability, which is 2/3. When you add these things up, you can see we get 3/3, which is equal to 1. So yes, this is a probability distribution. Now, I've done a bunch of examples. There's only 3 of these things, but this list can be actually countably infinite. And the next part where I show statistics on these things, I'll use larger lists. So again, please consider subscribing, liking, and sharing. Thank you.